Okay, to find the resultant force in this question, we can use the formula. Resultant force is equal to MA, and the mass is equal to 12,000 kg multiplied by the acceleration, which is unknown. Okay, however, we are given the initial speed of 10 meter per second, u, and the final speed of 30 meter per second, and the time taken is 16 seconds. So we can use the formula A is equal to V minus U divided by T, and that will give us 30 minus 10 over 16, and this is going to give us 1.25 meter per second square. And when we sub in the acceleration here, 1.25, we will get the answer as 15,000 Newton. So the answer is C. Okay, in this graph, right, we see that the volume reaches a minimum at 120 degrees Celsius, and the volume reaches a maximum at 180 degrees Celsius. So since the density is equal to the mass over volume, when the volume is a minimum value, right, the density will be at its maximum, and when the volume is at its maximum, the density, it will be at its minimum. So the answer here, it should be density is maximum at 120 degrees Celsius. Answer A. Okay, we have a meter rule that is pivoted at the 30 cm mark, and it weighs 1.5 Newton, and since it's uniform, the weight of the ruler, 1.5 Newton, it will act at the 50 centimeter mark. And there is another weight of 2 Newton that is being hung at the 15 cm mark. So this 2 Newton force is going to create an anti-clockwise moment, and this 1.5 Newton is going to create a clockwise moment. So in this case, clockwise moment is equal to 1.5 multiplied by the perpendicular distance of 20 cm. So we will have 30 Newton cm, and for anti-clockwise moment, it will be 2 multiplied by the perpendicular distance, which is 15, 2 times 15, and that will give us 30 Newton cm as well. So since the clockwise moment and the anti-clockwise moment, they are the same, they will cancel out, so the resultant moment, it will be 0. Answer A. Okay, in this question, we have 4 weights with different area of contact with the ground. So we are supposed to find out which object will exert the greatest pressure. So it's recommended that we add in one more column to calculate the pressure in Newton per cm square. Pressure in Newton per cm square. So option A, we will be taking 30 Newton divided by 100, so we will get 0.30. Option B, we will take 500 divided by 150, this will give us 3.33, and if you take 750 divided by 300, we'll get 2.50. And the last one, 10,000 divided by 4,000, we'll get 2.50 as well. So the greatest pressure, it will be B. Okay, in this question we are given a manometer. So when the gas supply is being connected on one side, the liquid level actually rises on the other side. So this is the equilibrium position. So we can form an equation. Pressure of the gas supply is equal to the atmospheric pressure here plus the pressure of this column of liquid, and this column of liquid is equivalent to 10 cm to 50 cm is equivalent to 40 cm of the liquid. So we can say that the excess pressure of the gas supply above the atmospheric pressure is 40 cm of the liquid, which is water in this case.